Hello dear students, so we are going to see what are the other solutions for overfitting apart from whatever we have studied so far. So quickly moving on and looking at the next solution. So the next solution is a dropout. We already call it as a dropout layer also. So dropout exactly means it to essentially drop a particular neuron from your input layers or hidden layer. I mean, not using a fully connected model, basically dropping certain neurons in between. Okay, to be very precise. Now, multiple neurons are removed from the network. Practically, that means they do not exist. Their incoming and outgoing connections are also destroyed. So, this artificially creates a multitude of smaller, lesser complex networks. So, this forces the model not only to become solely dependent on only one neuron, I mean, it has to diversify its approach and to develop a multitude of methods to achieve the same results. Okay, so this is method called dropping, and you also have, you call it as a dropout layer wherever you want to drop a particular connections of neurons. More on this dropout layer you will be learning it when I'll teach you convolutional neural network, that in depth we are going to study about dropout layers. So for now, if you understand the concept of dropout, it is sufficient. So, dropout is actually applied to a neural network by randomly dropping the neurons in every layer, including the input layer. So, for doing this, there is a specific dropout rate which you have to predefine. So, a predefined dropout rate will determine the chance of each neuron that is being dropped. For an example, if you set the dropout rate as 0.25, then it means that 25% it is a chance of a neuron to be dropped whenever you are calculating an output. So dropout is applied during every epoch during the training of the particular model. To understand it better, just look at this particular structure. Onto the left hand side is a standard neural network where it is a fully connected model. Each neuron from every layer to every other layer is fully connected. So there are a lot of calculations it means. So it's going to be more complex network, and it may lead to more overfitting of a particular data. So if you apply dropout layer, then precisely you can make it a much simpler model, and choose a suitable dropout the dropout percentage or dropout rate, and check for your output. You can even play with your dropout rates and get a proper output based on the scenario of application. So this is very simple and precise note on dropout. Again, I am telling more detail. I'll be teaching you this in when I'll teach you CNN. Okay, so this was about dropout. Now, what is the next type of solution again to avoid overfitting? It is data augmentation. So most of you might have familiar with this word called augmentation because you are already learned machine learning so far. So one of the best techniques to reduce overfitting is to increase the size of training data set. So you have been hearing this. Your data set should be enough strong to train your model. Okay, insufficient training data set can lead to overfitting. So to avoid it, you have to increase the size of data set, and the best one of the best techniques is to use data augmentation. So it is like that the to increase the size of your training data, that is to increase, let's say, data augmentation is mostly used when you are dealing with CNNs or whenever you are dealing with an image type of a data. So to increase the number of the images which is present into your data set, what you can do is you can very easily go for data augmentation to avoid overfitting. So it is the easiest way to diversify the quality of our data and to make our data set training data set large. So there are various techniques in data augmentation that we can see. A few of them, if I want to mention, then it will be flipping, rotating, scaling, cropping, adding brightness, adding noise, etc., and then reusing the same image. So you'll see most of it in detail. I'm just helping you to understand what exactly is data augmentation. So image augmentation technique, specifically if I talk, then you can see there the same image can be used in multiple ways where you are adding certain hues, certain brightness, certain saturation, clockwise, anti-clockwise, cropping, zooming, all of these techniques, and you can augment one single image into so many other images. So that was about image augmentation. Now you can also see that augmentation is not only restricted towards image. You have got text augmentation also, time series augmentation also. So we'll see that now. So first, if I talk on image augmentation, there are several ways by which I can augment a particular image data. It can be rotation, it can be flipping the image horizontally, vertically, you can zoom in or zoom out of the images, you can resize the images, you can randomly crop a particular image to completely change its dimension, you can shift the image horizontally and vertically, that is translation, you can adjust randomly the brightness and the contrast of a particular image and reproduce another copy of it. You could add some random noise to the images, you can add some color details by adjusting the brightness, saturation and the color hue of a particular image and reproduce several images with it. So that's how you can amplify the amount of your training data set, particularly if you're using image data set. Now what about text data? So inside text data augmentation, you can go for synonym replacement, wherein you can replace a word with their synonyms, you can go for random deletions, you can go for swapping, you can go for back translation, that is translating a text into another language and then back to the original language. You can go for insertion. So these are all the ways wherein you can augment a text data. Suppose you have got a time series data, then you can go for time warping by compressing or stretching it. You can add some random noise to your data, which is called as jittering. You can apply rolling window transformation to create new data points. If you're working with audio data, then to avoid overfitting and achieve augmentation, you can go for pitch shifting, wherein you can change the pitch of a particular voice inside that audio file. You can go for time stretching, noise injection, speed perturbation, wherein you can change the speed of the playback of the particular audio file that you are using. So these are the ways where you can increase your audio data. If you are working with a tabular data, then you can have several methods like feature scaling, wherein you can scale your features within a certain range, where you can have a feature selection, wherein you will select a particular subset of the features. You can even go for data perturbation, that is adding certain noise to a particular data. And the most commonly used type of data augmentation these days specifically is your data generation. So synthetic data generation is what we call. The very popular GANs and VAEs come into picture. We have a perfect unit 5 based on this GAN and VAE that I'll teach you in detail again, but for now you can understand GAN stands for generative adversarial networks, and these generate synthetic data samples that are going to mimic the real data distribution, and VAE are variational autoencoders which create new data points from the latent space of the VAE. So I'm just stopping here with the definition because we are going to see them into detail when we move on to our unit 5. So these are all the various commonly used data augmentation techniques in order to avoid overfitting. So we have now learned good about underfitting, overfitting and various ways in order, various solutions to overcome overfitting. So this was about underfitting and overfitting.